Let us know how to construct a triangle similar to a given triangle as per scale factor. For that, consider the example question. Draw triangle ABC with sides BC as 6 cm, AB as 5 cm, angle ABC as 60 degrees. Then construct a triangle whose sides are 3/4 of the sides of the corresponding sides of triangle ABC. So first let us draw the given triangle ABC where base BC is a 6 centimeter. So let me draw a line segment of length 6 centimeter. And later we will have to construct 60 degrees at B. For that purpose, first let me label the line segment ends. So this line segment is BC. At B, we have to construct 60 degrees. For constructions, we will only use circular, that means compass. We will not use protractor, as protractor is a verification device. And how to construct a 60 degrees? For construction of 60 degrees, on the circular, we have to take a certain radius. How much radius? Perfectly okay, any radius. With a certain radius pointer at B, we draw an arc. Now with the same radius pointer at the location where I placed, and turn the pencil and cut an arc on the just constructed arc. And when we join point B to the point of intersection of these two arcs, angle 60 will be formed at B. So I joined this B to the point of intersection of arcs, but before that B, this has to be placed properly at B and the point of intersection of these two arcs. Once it is placed properly, then we will join. Right. So now let us join B to the point of intersection of arcs, and as we move forward, we will get angle 60 at B. Now, since AB is 5 centimeter according to the question, so at B I place the scale, and measuring 5 centimeter, I will mark a point. Measuring 5 centimeter, I will mark a point. Yes, and after marking the point, I will label the point as A, and then we will join. This point is A. And we will join AC, and then we will have our given triangle, and our real construction begins from here, because we have a given triangle and we have to construct another triangle that is similar to this given triangle on scale factor. And what is a scale factor? Our constructed triangles, every side is a 3/4 the sides of the triangle ABC, which is considered as the given triangle. So we have triangle ABC right now. Okay. Now, once we have drawn the triangle ABC, we have to construct another triangle whose sides are 3/4 of this triangle. For that purpose, at B, we have to draw an acute ray. So I just place the scale at B, and we will draw an acute ray. Yes. Okay. And I do something like this. Point should have touched C. Okay. And the name of this acute ray, let us call this as a BX ray. BX ray. Now, look into the ratio or the scale factor. We have to construct another triangle that is similar to the given triangle ABC, whose sides are 3/4. Whose sides are 3/4 times the sides of the given triangle. 3/4, when you convert to a decimal, we will get this less than 1. So our constructed triangle will be smaller than the given triangle ABC. That we will see after the construction is done. In this ratio 3 by 4, the highest number is 4. So 4 number which is highest, that many number of equal arcs we have to construct on the acute ray BX. Then in this fraction, the denominator number is for joining to the other end of BC, and numerator, at the numerator numbered division, we have to draw line parallel to the joined line. Now, the highest number is 4 in the ratio 3:4. So, let us mark 4 equal arcs on the acute ray BX. So let me go for the first arc, then the second arc, then the third arc, and then the fourth arc. So we have 4 equal arcs. Yes. And now let me name these equal arcs as arc B1, B2, B3 and B4. So these are 4 equal arcs. In this fraction, denominator number is for joining. Where to join? We have to join the fourth division to the other end of line segment, BC, because at one end we have drawn acute ray. So at the other end, we have to join the last division, because the denominator number has to be joined to the other end of line segment BC. So I have placed the ruler between C and the point of intersection of arc and the acute ray. Now we have to join this, and I'll go for a thin line. So joining B4 joining B4 to C. Now once we have joined this, numerator division is 3. Numerator in the fraction 3 by 4, numerator is 3. So at the third division, we have to draw a line parallel to the joined line. As we have learned in the previous videos, for drawing parallel lines, we will not slide scale and draw parallel lines, neither that nor we will use a protractor for constructing equal corresponding angles. So the procedure for drawing parallel lines is place the circular pointer at B4 and take a certain radius. How much radius? We can make out then there is no particular number for the radius that has to be chosen. So pointer at B4, we have to draw an arc intersecting the joined line and the acute ray, and with the same radius, put the pointer at B3. Why? Because at third division, numerator number is 3. At third division, we have to draw a line parallel to the joined line, that is B4C. So pointer at B3, draw another arc. So once pointer at B4, next pointer at B3. Now measure angle B, B4 and C. And how to measure the angle? Put the circular or compass pointer at one of the point where the arc that we have just drawn intersects the yellow line, that is acute ray, and the joined line, that is white line. This we have to measure. And since the circular is not going very close, okay, so we will take a scale and we will measure the gap. So I place the scale between this point and this point so that I know what is the radius. And now the radius here is, it should be done very perfectly. Radius is at 2.3. So this gap, my cursor is showing you the gap, 0 to 2.2. 2.2. So we have measured this angle. Now on the circular or the compass, take a radius of 2.2. 2.2 is not possible. 2.6 is the minimum. So what we do is, since the circular doesn't go for 2.2 radius, so we'll take the ruler, place the 0 of the ruler at this point where it is placed right now, and go for a 2.2. That means turn the scale so that it meets the blue arc which we have drawn with center at B3, comes at 2.2. Now mark the point where you see 2.2. Yes. And after this, once the pointer is marked, then we have to join. Yeah, I just make the mark a bit strong. This is the point, right? Join B3 to the point of intersection of arcs. So I'll place the scale between B3 and the point of intersection of arcs. Okay, and we have to draw a line up to, line segment BC. So B3 to the point of intersection of arcs, and we go up to BC line. Yes. Then the line segment B4C will be parallel to the newly constructed point. This point is C prime. So here by construction we have B4C parallel to B3C prime, right? Now once we got parallel lines, now B3C prime is parallel to B4C because we have constructed equal corresponding angles. So if corresponding angles are equal, then lines are parallel. So we have to be very cautious on the accuracy of construction of the corresponding angles. They should be equal. Now at C prime, we have to construct angle BCA. So place the pointer at C, and now draw an arc of a certain radius. It is like certain radius. So see a center, an arc of certain radius. With the same radius, pointer at C prime, draw another arc. So here also we are going to construct equal corresponding angles. So yes. Now see how much is angle BCA, and how to see, place the pointer at this location where I have placed, and the circular pencil pointer adjustment. And if we are not able to do with the circular, because circular minimum it will go for 2.6, then take the scale and see what is the angle between this point where I have shown the cursor, this to this. That means that will tell what is the angle BCA. That angle BCA we have to construct at C prime to have BC prime A prime. Okay, right. So the 0 is placed here. Now as I have to make the ruler still small. Okay, so 0 is placed at this location. Now as I turn this, so this gap is the approximate 2.2. So this gap we have to measure. And then since the circular cannot read less than 2.6, we place the scale 0 here, and on the arc we will see where is the 2.2, and accordingly we will set the scale. Now let us mark the point on the arc where we are able to see 2.2. So I have marked the point. Now we have to join C prime to the point of intersection of these arcs. So I'm just turning the scale. Place the scale between C prime and this point which we have just created an arc. C prime to this point, and join C prime and the point of intersection and go up to line segment or side BA. The point where this line meets BA is A prime. It will be labeled as A prime. Now A prime B C prime is the required triangle. A prime B C prime is the required triangle whose sides are 3/4 the sides of triangle ABC, and which is similar to triangle ABC also. So how do we prove that each side of A prime B C prime is a 3/4 ABC? Here in the justification, since angle B is equal to angle B, it is common to both the triangles, and let me erase this part so that I'll write the justification here. And angle, right, angle BC prime A prime is equal to angle BCA. This is by construction. And what did we construct? We constructed corresponding equal angles. So line A prime B prime is parallel to AC. So here, since we have pair of equal angles, we will declare triangle A prime BC prime similar to triangle ABC. Why are they similar? They are similar because of angle-angle similarity criterion. As a result, we can write a side of the constructed triangle, that is AB prime by AB, is equal to BC prime by BC, which is in turn equal to A prime C prime by AC. This is because corresponding sides of similar triangle are proportional. Now, on the parallel side, let me show you, since I just run a since bracket and just change the color of the pen so that, yeah, since B3 C prime is a parallel to B4 C by construction. So when we apply basic proportionality theorem, we will get BC prime by C prime C is equal to B3. Okay, we can write corollary instead of writing the BPT. We will use corollary of BPT. So since line B3C prime is parallel to B4C, we will write B3 by B4 is equal to BC prime by BC. But B3 is 3 divisions and B4 is 4 equal divisions. As a result, we will have BC prime by BC is 3 by 4. Now let us call this as equation 1 and this as equation 2. And in the left side of the construction, from equation 1 and 2. In equation 1, in place of BC prime by BC, we can plot 3 by 4. As a result, we will have AB prime by AB is equal to 3 by 4. And on simple cross multiplication, we will get AB prime, means side of our constructed triangle, is a 3/4 of AB. So this is one side of the constructed triangle, 3/4 of the given triangle. Also, when we see the other ratio from equation 1, in place of BC prime by BC, if we write 3 by 4, then we will have A prime C prime by AC is also equal to 3 by 4, and we will go for cross multiplication, and then we will have A prime C prime is 3 by 4 of AC. So this is the other side of the constructed triangle, which is 3/4 of the given triangle. And the last one, see equation 2. In equation 2, we have BC prime by BC is equal to 3 by 4. And here when we cross multiply, we will have BC prime is 3 by 4 of BC. So from all the 3 outlined statements, we understand that our constructed triangles, each side is a 3/4 the side of the given triangle.